Hi, hello everyone. This is Vishwajit once again on behalf of strictlyba.com. Yes, as a part of basics of SQL training on lesson 2, today we are going to discuss more in detail about the normalizations and the constraints part. The constraints and normalization has to be known by SQL developer, and we are going to discuss more in detail. The normalization process is no way can be explained. We are not going to discuss more in detail about the normalization process, but I'll give you the basic idea about the normalization, why it is and what it is and why we need the normalization. Okay, let's jump into the session. Okay, what is normalization? Normalization is nothing but arranging the data, arranging or organizing the data in a better manner. So how do you organize the data? Where do you organize the data? You organize the data in tables. The tables are located at databases. So what is normalization? Organizing the data in a better manner. So why we need to organize the data in a better manner? So why we need that? So say for example, if a table, so then and also at the same time the use of normalization is that it reduces, it eliminates, not reduces, it completely eliminates the data redundancy. Sorry, the data redundancy, and it also eliminates data duplications. So what is data redundancy? Say for example, you are having a table, the unwanted records. If at all the records are not in needed, that can be classified as a data redundancy. Okay, do you got me?
Yeah, that is bad data.
Yes, not in a real time bad data. So if at all that data is not being used, that becomes wastage, that becomes very wasteful data here in databases. So it occupies more spaces. So we need to eliminate the normalization process eliminates the data redundancies. So as you said, it's like bad data also we can consider as a bad data. Okay, very well said, Arun. Okay, yes, and why we need a normalization is that why we need to organize the data in a better manner. Why do we need that? So what happens if you are not organizing the data in a particular manner? What happens
if we query the table? Then query will be running long time, or the performance will be decreasing.
Yes, that's correct. The performance decreases without normalization. Without normalization, the performance decreases, and also at the same time the data redundancy happens. So many duplication occurs. And so on. So in order to do that, there has been a separate protocol that has been told on the normalization process. So this is what you need to follow in order to maintain your data. Protocol is nothing but a set of rules that needs to be followed in order to organize your data in a better manner. So normalization is nothing. So there are types of normalization available. So types of normalization. Types of normal forms actually. Form 1. Okay, that's normal form 1. What it really defines is that it doesn't allow each and every record has to be unique. Okay, this is what the normal form 1 says. Each and every record has to be unique. Say for example, you're having a table A. Okay, so we are having a columns as EID, E-name, salary, department. Okay, let's find it out. Okay, and the employee ID is like 1, and then E-name is like Vishwa, and salary is like 20,000, and department is like sales. Okay, if this guy lies with both departments, he belongs to an IT and he belongs to sales also. Okay, and for record 2 we are having Gopi, and his salary is 30,000, and he belongs to HR, and also he belongs to admin department as well. Okay, consider this table. We are having this table. So what is the normal form 1 says? Each and every record has to be unique. Each and every record has to be unique. Okay, consider the table A. Do you think this table has unique records? Say here employee ID is ID1, Vishwa, 20,000, sales, and ID. It seems to be unique. Correct, right?
Yeah.
It seems to be unique, but it is not. How? Say here as consider this row. Vishwa belongs to both the departments like sales and IT. He belongs to both sales and IT. Okay. Why it is? I'll say a better way. Why it is not a normalized one? Why it is not? Why it doesn't have the rule of normal form 1? So when you try to update this record, say for example, you want to change Vishwa later than from sales. Later he moved to production. You want to update the records in this table. What happens? Can you really update? So what does that update statement says? Update
Table name,
set
column name.
Okay, department. So no worries guys, we are going to see more on this query linking and update statements and so many items. So please don't worry, just listen on this. We shall deep in dive later classes on this query. So this is what the update statement says. Update table name, set, this is the column name, So
name.
production. So what is the thing that you have going to be like you want to change? Sales to production. Update the table name, set department is equal to production. We have to give where condition, where EID equal to 1. Does it really work? Does it really work? No, because in department we are having sales and IT. Okay, sales and IT, but we want, instead of sales, we want the department as production, or else we can have other run condition also, where department equal to sales. Does it sound really a good query on querying this? Do you really get any records from this? Say here you are going to change from sales to production. Here this is sales, you want to change from sales to production, but see here we are doing the same. Department is, we are setting the department to be production, where EID is equal to 1. Till then we are good. Okay, so where we need instead of sales we need production. So and department equal to sales. Shall we give this? Shall we give this? We can't give, because here the entire string is like sales comma IT. Okay, sales comma IT, it is like this. You cannot change this one, you cannot change this one, you cannot give this one. So this entire table doesn't accept the normal form. So what is the rule of normal form? Each and every record has to be unique, but this table doesn't have a unique records, but it seems to be unique, but it is not. Since it has 1, 2 and ID columns, it seems to be unique, correct, right? But see here there are two departments with comma separated items. So when you are trying to update this one, you cannot update, instead of sales you cannot update production. You nowhere, we have already tried here, right? Nowhere we can update this one. Do you have any questions? So please let me know, then only we can move forward on this.
Yes, we can proceed.
Okay, because we can, in where conditions we can only give where department is equal to, or department like, or department in, we can give that. But here the entire string is like sales comma IT. Our requirement is to change sales to production. We cannot do this. So this type of tables doesn't satisfy the condition of normal form 1. So that is the protocol of normal form 1, like each and every record has to be unique. Okay, then how can we convert this into a normal form? So as I said, like normalization is the process of organizing the data in a better manner. So this data is not in a better manner. This data is, since we couldn't update this record, since we couldn't do insert also, since we couldn't do delete also. Say for example, so this is an update anomaly. So you cannot update properly, right? Okay, this is an update anomalies. Anomalies is nothing but the thing that you can't do, and delete anomalies. So how to find, another question everyone will ask, like how to find whether this table is normalized or not. The simple thing is like, first to see the normalization, whether it is satisfied the normal condition, normalization form 1 or not. What does the normalization form 1 says? What does our normalization form 1 says?
Yeah, each and every record has to be unique.
Yes. Does this table has an unique records? No, right?
No.
Since that's what I explained, like we cannot able to update this particular sales. We cannot do that. Instead of sales, we cannot. We were not able to update production, right? Okay. We cannot update into production, and also at the same time there will be a requirement delete only the sales. Delete only the sales. There will be a requirement delete the persons who are all working in sales, who are all in sales. So how can you delete it? So what is the syntax for delete? Is come on up.
Yeah, delete from table name.
Okay, table name.
Where condition.
Yeah, what is the condition? Here it says. So I want to delete only sales. Delete the persons who are all in sales.
Where department is equal to sales.
Okay. We are going to table is nothing but table A. We are querying against this table. Okay. Does it really work?
No.
Because department is equal to sales. Here we are having sales comma IT. Okay, this is, as I said, this is an entire complete string. You cannot do this update or delete or insert here. That is what the delete anomaly says. So it again caused an issue with delete also. So when you're trying to run this query in SQL Server or Oracle, you will against this table you cannot delete any items. It says no records deleted. So 0 rows updated, 0 rows found. So you cannot do that. But if you want to change who are all in sales and IT, you have to give this entire string. Then only you can do this delete. But this is nothing but a string, man. String, guys. Don't worry on this thing. What is command? This is an entire string. But I want to delete only the sales. It cannot be done. It cannot be done. No way it cannot be done. Okay.
Okay.
So do you have any questions on me?
No, we are clear.
Okay. Yes. Again, I'm saying it's like how can and again I'm saying it on a very deep manner on normalization form 1. Yeah, that will be a question how to find whether this table is normalized or not. Is how will you get to know this table is normalized or not?
The record should be unique.
The record should be unique. Okay. The record has to be unique. If the record, how will you find this record is unique or not? You can easily find in three ways. One is update, delete. So run update statement against this table and find whether the update runs or not. If the update doesn't runs good, then it doesn't satisfy the normal form 1. And also run a delete statement against this table. If the delete statement doesn't satisfy your nation, then it doesn't satisfy the normal form 1. Okay. I think we are clear now, and we shall discuss more in the we shall discuss on normal form 2. Okay.
Okay.
But wait, I forgot to say that. Okay, how can we convert this table? Okay, this is an existing table. Okay, Vishwa, this is an existing table I have. I want to convert this table into a normalized manner. How can I do that? Yes, of course, the normal form. What is the what is the normal form says? Each and every record
has to be unique.
Each and every record has to be unique. That's really great. So it can be like this. Okay, so this entire record is unique. Is that right?
Yes.
This entire record is unique. Don't worry about the keys. Don't worry about the EIDs. I'll tell you, we are not into the deep concept of EIDs. We are not discussing on the keys right now. So this record is not normalized. Okay, not normalized in the sense it is denormalized data. It doesn't satisfy the normalization form 1, normal form 1. So what does a normal form says? Each and every record has to be unique. So instead of having a comma, we can split the larger data into simple data and we can have in a separate row. So this becomes an each and every department for each and every item, it becomes an unique. Okay. Where yes, when you query, update, delete and insert into when you run this update, delete and insert, you can do. Yes, shall we try this one? Like update sales information. Yeah, this one we are doing here, right? Sales to production. We are doing sales to production, right?
Yes.
Sales to production. I want you to run this against this table. Will that work? Update table name, set department is equal to production, where we should not concern about this EIDs and all because it is not where department is equal to sales. Does it really work?
Yes, it will work now.
Yes, definitely it updates this record alone. Previously the update doesn't work, the delete doesn't work, the insert doesn't work. Now the update really works. Same way, if we want to delete the person who are all in sales, we can straight away give sales. So what is the record? It will be deleted. It will delete this record alone. Okay. Insert, update, delete anomalies will not be found in normal forms, especially in normal form 1. Okay. Now deep dive in normal form 2. Okay. So normal form 2 has all the nature of normal form 1. In addition to that, it has other protocol as well. So let's take, like, here it satisfies the normal form 1, so we shall take this table. Okay, we shall take this table and we shall do. Okay, what does normal form 2 says is like it also says that each and every record has to be unique, and it more particular, the table has to carry a key, that is a primary key. The table definitely should have a key called primary key in order to identify the data So it should have a key, that is a primary key column. Okay, yes, we stop here on normal form 2, and I shall discuss on the keys. We'll get back to you on normal forms 2 once we are finished with the keys. So what is a key? So key is nothing but a column that serves or plays a major role on connections, on eliminating duplications, key is nothing but, in cricket we used to say like the key player is Virat Kohli. So the same as that, in databases the key has to be maintained. So the key to success is like Virat Kohli and Suresh Raina and MS Dhoni. So the same has to be maintained in that particular column. So what is a key we have mentioned, and we are going to detail on primary key. What is a primary key? So primary key is much more important. It is a constraint here. So guys, please listen, please be awake. Please, the last bench students, please. Yes. Great to hear that you are awake. Yes, this is an important concept in this entire databases, like constraints. Primary key is a combination of unique and not null. Okay, first get to know this theoretical part. I shall discuss more in detail on the practical scenarios later. So it's a combination of unique and not null keys. Okay, so what is unique key?
Without duplicates.
Yes, without duplicates means it does not have duplicate values. What is not null?
No null value.
Yes, it does not allow null values. Okay, these keys are can be specified on column levels. Okay, on column levels, on top of the records. If you want the record to be unique, if you want the column to be unique, you can straight away mention. Say for example, the same table we shall consider. No, I'm not comfortable on using this. EID, rename, email, salary, department. Okay, here ID 1, again Vishwa, email. Here the email has to be unique. The email has to be unique. So no persons will have the same email ID. The unique key is nothing but, if you are specifying email column as a unique key, it doesn't allow any duplicates. So if Vishwajit at gmail.com is already found in that email column, when you are trying to insert again, you are trying to insert on the second row and again Vishwajit at gmail.com, it doesn't allow you, because since you have defined email column as a unique column, that column key violation occurs. So uniqueness is maintained. Uniqueness is nothing but only a single record with a single name at only one time can be accommodated. Okay, they got my. And for ename you can specify not nulls. If you are specifying ename as not null, that column has to be filled up with some value. Okay, on practical sessions we shall see more in detail on this. So you just get to know what is key is. So again, what is an unique key? Unique key is nothing but, if you are defining email as a unique key, it doesn't have any duplicate values. It doesn't allow any duplicate values. Once you have inserted a particular record, it doesn't allow the same record to be inserted once again to that table. Okay, what is not null? It doesn't allow any nulls. Okay, the null values, it doesn't allow the null values to get into the database. Okay, then unique key, and then primary key. It's a combination. Primary key is nothing but it's a combination of unique and not null. Yes, why do we need unique and not null? What does a unique says? Unique key is particularly unique. It doesn't allow the repetition, it doesn't allow the replication, but it allows null. It allows one unique key allows one null. Okay, so when it is on unique and not null, the primary key comes into the picture. Okay, consider you have defined primary key on EID column. Okay, so when you are trying to insert again something and again something, when you are trying to insert this record, you have given EID as some primary key constraint, but it doesn't allow you because it is violated. Because unique key, because primary key is a combination of uniqueness. The uniqueness has not been maintained here, right? Because already one is there. You have to give one different number, so that is 2. Then it can be it can be inserted. Then many people will ask, why then we can have unique key on TID, right? Then why do we need primary key on this column? Yes, unique key. Yes, primary key is not null. Unique key has null values. If we give like this also, if you have defined EID as a unique key column, if you give null value, if you pass null here, it takes null values. Okay, but we, as a part of primary key, it's a combination of unique and not null. Why do we need a primary key? That is much more important on normalization process, on table levels. When you are trying to get a record, this is like an ID column. When you are trying to get a record, each and every record has to be unique with some particular row. So you cannot, there will be so many Vishwajit, so many Vishwa, so many Arun Kumar, so many Gopinath, so many Gopals will be there, so many Rajesh will be there. We cannot get data based on the e-names. Okay, some people will also say, why can't we get names on names by using that email column? That will be better. No, yes, of course it will be better, but for maintaining this email column you need one key for that. So if you are defining some column as a primary key, it will be much faster than you are defining as a unique key. Why? Because when you create a primary key, nowhere in the other sessions you cannot find this one, index is automatically created. Index is created automatically. Okay, what is the index? Index is the clustered index. Clustered index is automatically created on top of EID, on top of the column that you are specifying as an. So what is the use of clustered index? So index is nothing but it increases your performance. It increases your performance. As I said, like you cannot search, you cannot put a select query, select ename from, select star from table 1 where ename is equal to Vishwa. There will be so many Vishwa will be there. There will be so many Arun Kumars. So the duplicates of record occurs. So in order to maintain some, the data in organized manner, that is what the normalization process is really up to, guys. Please listen to me. So in order to maintain the data in a particular manner, we need this primary key. Okay. So the primary key eliminates the duplication of records. So if we are not having a primary key, if there are two Vishwa, what does happens? What does happens with you guys? Sorry, some error occurred. So there will be so many Vishwa, there will be so many hundreds of Vishwa will be there, hundreds of Gopals will be coming there. So then the data is redundant, then the data is duplication occurs, then it is difficult to handle the data. So that is what the normal form 2 says. You should have a key column, that is a primary key column. Okay. Okay. So we have studied important thing, unique, north null, and primary keys. When you create a primary key, the clustered index is automatically created. So what is the use of an index? We shall discuss more in detail on the later classes on index also. But keep in mind, index increases your performance. Index increases your performance. Index. By using index, you get to retrieve the data from the database in a faster and efficient manner. Okay. We shall discuss more about in detail. I'll give you the real-time examples of an index in our later classes. So as of now, we have finished 2 normal forms. There are so many concepts in normal to discuss in normal form 1 and normal form 2, but I want to give you the basic scenario. What is the real aspect of going for the normalization. I just want to know, give it to you. And remaining things I want to leave with you guys. Okay, this is what the entire session is up to, and there are 6 normal forms, and we are following like nearly 4 normal forms, and yes, we have completed with 2 normal forms, and we shall discuss what is the normal form 3 is. Okay, the normal form 3, it accommodates, it is a combination of n form 1 plus n form 2. In addition with that, its own uniqueness, its own feature. What does a normal form 3 says? If at all a table has to be, a normal form says like each and every row has to be, each and every data has to be unique, and each and every table has to be unique, and also each and every has to maintain with some key columns, that is a primary key columns. And what does a normal form 3 says? Instead of having data in a single table that becomes complex. When you are handling large amount of data. Okay, when you have that becomes a so what is the solution of normal form 3 says? So when you are having large amount of columns, when you are having large amount of data, you better create a separate table. What does it say? You better create a separate table and give the relation between these 2 tables. That's it. That's the concept of RDBMS that we discussed in first session. Yes. Okay. Better create a separate tables and maintain the relations. Let's maintain the relations. Here comes the picture of foreign key constraint. We shall discuss that in detail also. Okay. Say for example, I'm having a table A. Again the same example. Email, salary, and department. So this is what our table is up to. Maybe I shall copy this one. So because we are already didn't take much time on this class, because I'm again and again saying like this is an important topic, but don't worry guys, like normalization form, when you apply in practical real times, you get to know, okay, this is what we are doing, this is what, okay, that is an easy thing only, but I need to get to the basics. Okay, consider the table is like this. Okay, what is a normal form? And this satisfies the normal form 1. Okay, but it doesn't satisfy the normal form 2, because since the key is not maintained, it doesn't satisfy the normal form 2. But now it satisfies normal form 1 and normal form 2, right? Yes. What happens here? Our motto is like create a separate table and maintain the relationships. It is a foreign key constraint. So create a separate table on that. Like say for example department. For department create dptid department name, okay, and locations. So this is table B or a department table. This is EMP table. Okay. So instead of having all the records in a single table, so imagine if there are n number of various amounts of records, what does happens? So we shall maintain the sales information, we shall maintain the department information in a separate table called as department. Sales information will be there. Sales is like Bangalore. What is the department ID? We shall maintain some IDs on that. 2 IT Chennai. So similar to that, HR and admin. So here we shall have this. Wait, we shall create this. It's a new table so that you can get to know. Shall have this as a ID. So sales is nothing but 1, ID is nothing but 2. Okay, and similar to that, and I shall give okay, and let's have it like, because I don't want to confuse 10 20, we are having 10 20. Okay, we shall give the same one here, 10 20. So the confusion here occurs. Right, the confusion literally occurs here. What you have just done, I really can't able to understand. Yes, we have splitted this table into two different tables. That's what really happened. Okay, wait, I shall do this also so that we should not be much more worried. HR and that is temporary. Admin and that one is Richie. Okay, so we are maintaining different tables because I don't want to dump more information on this table. Okay, instead of dumping more information on a single table, we can split the single table into two different tables or many different tables. That is one-to-many relationships, many-to-many relationships. So that is what the concept of normal form 3 is. So instead of having a single table, why can't we split that information into two different tables? So here I have changed the department. So I'm having a separate table called department table, and this table is exclusively for department level informations. Here I'm maintaining a key. Did you agree with me? I'm maintaining a key column as we have discussed with the key columns 10, 20, 30, 40. Here I am giving the same as 10, 20, 30, 40. Okay, so if he belongs to 10, then you have to come here and look who is 10, sales. Okay, Vishwa 10 belongs to sales. Okay. Vishwa 20 belongs 1 EAD 1. Vishwa 20 belongs to IT. Okay, so this is the relation. So this is how can we relate. So by giving this one we can straight away say that we have satisfied the normal form 3. Is that true? No. We have to satisfy the foreign key constraint. So foreign key is nothing but, it's another important key. Foreign key is nothing but it maintains foreign key maintains parent and child I'm losing out of control. Parent and child relationships. Okay, say for example, so this is the parent table, this is the parent department table. Okay, this is the parent department table. You are having only, so what is the use of foreign key? You cannot enter a duplication value. You cannot enter a value that is not specified in the table. Yeah, I'll explain in detail that. So this is the parent table. Say for example, department table is the parent table. It has 1, 10, 20, 30 and 40. Suppose a guy with zero knowledge on DB tries to enter as like tries to enter like this as 60 or 80. So it does not allow him to enter this record, because since this column department ID column has been given as a foreign key references to this table. So this column is a child, this column is the parent. Okay, say in real time, if a parent has only, if a mother is having something like kind of a Cerelac only, then only she can feed her children. If she doesn't have any items, if he doesn't have Cerelac to feed her children, then how can she? Similar to that, so this is the parent table. In parent itself, In parent itself there is no 80. Then how can he add to the child as 80? When he is trying to add this entire row, the foreign key violation will occur. Okay, first we need to add, when you are trying to add new department, first you need to add to the parent. First satisfy the parents, then the children satisfies themselves. So like 80, you can have it as support, and location as anything Lucknow. Okay. But after that, but now when he tries to enter this one, definitely it goes and sees whether this department ID is here in department table or not, and okay, the 80 is there, and it straight away inserts. There is no violation occurs. So please be aware that foreign key references is much more important. It maintains the child key relationships, like so if at all a mother has, if at all the parent has, if at all the parent key column has a values in it, then only it feeds to its child. If the parent key doesn't have anything, doesn't have any values, similarly the child doesn't have. Okay, that is what the concept of primary key, and that is what the concepts of normal forms. And in addition to normal form 3, EF code have derived normal form 4, and it is similar to that. You can create another lookup table also. Say for example, if this table has it contains department, right? If this table has a location also, location Bangalore, Chennai, specifying here, or you are maintaining sales information here on this particular each and every employee, you can have another like department table. You can have another table as salary or sales information by maintaining a separate table. That is what the normalization form 4 is. Okay, and the normal form 5 and 6, I think that is not really necessary. I just want to go through you guys, explore on this. Okay, explore on this. I think we are finished now, and I just wanna go through the quick as we normally do on this. I just want to walk through what we have discussed today. Yes, normalization. Once again, normalization is nothing but arranging one simple words. When you Google and see what is a normalization process, no one would give a very exact and top level information, because they will give, because normalization is a PhD course. So how far it can be normalized, so many theoretical, so many theses are there. So our motto is like to understand the basic and the base part of it. That's it. That's what I'm trying to explain all these through sessions, because this session took me so long, because I think this normalization is much more important to understand for each and every one of you guys, so that when you create a table, you always keep in mind that you have to arrange the data in a better manner. That is the normalization. You have to follow normal form 1, 2, 3 and 4 definitely. Okay, you should not follow any other items. Normalization in RDBMS, we have to follow normal form 1, 2, 3. What does a normal form 1 says? Each and every record has to be unique. That's what we have well said here. So if the record is going to be like this, split it up into two other records. Make this record into a single thing. Then we get to know. So here, so and also Gokul asked like how can we define. There will be some real-time scenarios. Some people will ask, there will be a requirement like this is a denormalized table. You have to normalize these tables. Okay, the people won't say this is a denormalized table. Okay, you only have to find whether this table is denormalized or not. So how will you find whether it's denormalized or not? Run an update query to it, run delete query to it, done insertion query to it, and find whether it is updating, it is deleting or deleting that exact scenario. So if it is not, if you are not able to update and delete, or if you are not able to insert, then you can find the data is in denormalized structure. Okay, so that is what, and we have talked much about normal form 2s, having a primary key and key columns. So I think we shall discuss later much more on the indexes later, and normal form 3, and on really on the foreign key references that we that is like foreign key is nothing but a parent and child relationships. If a parent has only, if a parent has some energy only, then only she can give it to her child. That is what the same as that of if the parent key column has some values in it, definitely the child, you can insert the same into the child. You cannot straight away go and feed the child. You have to first, you cannot go and feed the child. You have to ask, first you have to feed your mother and then by the child. Okay guys, I think we are set now, and thanks for, I know it's a pretty long run today, it took so long. Thanks for wasting your time guys. So but I think this video will be much helpful for you guys who are really want to know the concepts of keys, constraints, and and the normalization processes. So on the constraints, there are so many constraints available. I'm going to have another sessions on constraints. My next class is going to be more particularly on the constraints alone. Yes, because there are so many constraints, because I have explained here primary and foreign key constraints alone, unique and not null constraints alone. There are so many other constraints I shall discuss in later classes. And thanks for your time guys. Please support us. Please make a subscribe us on YouTube video channel Strictly BI. And thanks for all your time. This is Vishwajit Krishna signing off on behalf of strictlybi.com. Thank you. Thanks for your time. Thanks guys. Have a nice day.